Sure. Okay. Very good afternoon, everybody. My name is Dr. Zeeshan, and I'm going to give just a brief talk on various trends and uses of AR and VR with scope of e-learning in terms of education, how we can use these two technologies that are currently being appraised and praised and used widely throughout the world. Okay, I'm Associate Professor in Department of Information Technology from Faculty of Engineering and Technology. My specific domain of research work is again in terms of animation, graphics, multimedia. I lead a research group there and we try to work in this area a lot. So we have done various different projects in this area and we're working and talking basically in this area more often. So basically in terms of education, if we start from there, so we all know that whenever we talk about education and learning, there are basic 7 different styles that we try to focus and we try to work with whenever we need to digitize these terms. Being verbal, visual, music, and auditory. Verbal again means like a verbal communication. Visual again, it's a visual having graphics, images. Musical or auditory, again, this is another style of teaching, another style of another mode of teaching that is preferred by lots of people. Similarly, physical or kinesthetic teaching, usually involving physical education or physical involvement of students within a particular experiment or with a particular laboratory work. Logical or mathematical. Social learning, again, is another aspect, or solitary individual learning, and usually combination of these form of learning. So we usually categorize modes of learning in these 7 different styles, and it basically encompasses all codes. Each student has its own aspect, has its own different style of learning. So it's not specific that there one mode fits all, or 2 or 3 modes, or these are the only modes. Most students have their own aspects. Some prefer verbal mode, some people communication mode. Some are more appealing to the visual and physical aspects of education, depending on how those. Implementing technologies such as VR and AR basically into the classroom will modernize learning styles, or these learning styles, to ensure that the students basically find the topic more interesting, find the learning more interesting, and are more engaged towards learning. So rather than typical face-to-face or rather than typical reading just the books, now then the trends are that we tend to involve VR and AR so that students become more engaging with the learning. They become more interested, more enthusiastic, and they turn to memorize and keep those retention rate for a longer period. That's why many educationers still are very optimistic and predicting that the use of education with respect to VR and AR is a very promising field, and it is gaining more and more momentum as the time passes. Okay. So coming back to VR and AR, basically, these are technically 2 different technologies, but they fall within the same spectrum. Defining AR, it basically is a light augmentation where it uses a virtual world as well as a real world. So it combines the real world with a virtual world, and that's where we say it has a light augmentation, or it is not a true immersive experience in terms of VR, whereas VR we are referred to as a full immersive environment where the user feels as if he is inside that particular environment. So they do fall within the same spectrum, but technically VR and AR, they lie on 2 opposite ends. AR is not a fully immersive, it is not a fully virtual environment, whereas VR is based on the principle that it has to be a fully immersive environment where user feels that he is actually inside that particular room. So when we define virtual reality, we basically define it as in something that allows us to completely immersively feel and experience environment as if we feel the environment in the real world. So that's why we say it's a simulating real world as well. So when we experience virtual reality, basically we refer to in terms of being able to physically experience an environment. This is very tricky. This is where our immersive and virtual headsets come into play. These headsets actually allow us to experience an environment as if we are physically inside it. Okay? We need to have these head-mounted displays, and these head-mounted displays allows us to experience a real-world environment as a virtual environment. There are various different aspects to this virtual environment. Virtual environment basically uses these headsets with respect to 2 different visions for left and right eye. These left and right eye visions are then augmented within our head, and our brain processes these environments as if it is a virtual environment. Now, the key to this environment is that the user only sees this particular virtual environment. They do not see a real environment. So for example, when we are looking into a display, a 2D display, we are seeing with a particular angle, and with respect to that angle, we are also seeing our virtual environment as well. However, when you talk about virtual reality, we only see that virtual environment, and then brain only processes that virtual environment. Then the next key comes into the mind that we need to create an immersive experience to it. The immersive experience comes into play that when you move your head while you're wearing the virtual environment, the environment changes. It adopts to your head direction, your head axis, and it gives you that new image based on your direction of the head. This is where immersive feeling comes into play. This has been used in various different technologies, from military, where military targets are now being used to practice completely within virtual environments rather than training in physical environments. Learning environments, again, where students are completely immersed in a 3D environment, and they see a 3D object and they create those 3D object as if they are working in a real environment. Gives them a different illusion of learning. Similarly, the same aspect of medical science as well. I will explore a few of these things as we go along. So virtual reality is basically becoming very popular, and it allows us to interact with virtual objects, having a virtual feeling to it, and we immersively feel that we are actually using that environment completely. Okay. Similarly, virtual reality is also now being used for psychotherapy as well, where psychological therapy, physiotherapy, mental rehabilitation, for that purpose as well, virtual reality environments are being created for patients, for doctors, for people who have a flight scare, people who have a nausea effects. So we are trying to create, and we are trying to work on various different aspects of virtual reality, where complete immersive feeling is being created for doctors and every other aspect. Okay, specifically working where the application for learning is in terms of special children. In other words, when we talk about education, it's for normal people, but then there is another aspect of people in terms of learning called special education or special learning. So VR specifically is being taught and is being worked primarily on how we can use virtual reality to train, to educate, to motivate children who have a special needs, who have a certain disability towards the normal trends for the normal educations. So this is where a virtual reality basically is again being played, and my research as well. So we are trying to focus in terms of my own research. We are trying to work with this, how we can use virtual reality for special needs children having dyslexia, having a spectrum, autistic spectrum disorder, and so on and so forth. Similarly, we are also using something called augmented reality. Augmented reality is defined as a technology which combines 2 or 3-dimensional objects with something with the real world environments. Okay, so this is not a fully immersive. This depends on your digital devices, and it gives you a virtual object on that particular device. You do not feel as if you are inside that environment, but you see a virtual object representing your 3D environment on your mobile phone screens. What it requires, that it has a virtual mobile phone, it requires a 3D world and something called a marker. This is where the virtual reality comes into play. Through your cell phones, you detect a virtual marker from your real environment, and then on your screen, that virtual marker is replaced with a 3-dimensional or 2-dimensional object. So you can represent virtually any object on your real world with a digital object. Okay, the potential of combining smartphones and augmented reality for education is big. It has a huge potential to be worked on. It has huge potential to be discovered, and many application areas are still being working on that. AR in various ways could grant students extra digital information about any subject, any complex information, which makes them very easy to understand. For example, any scientific principle, any scientific phenomena, any medical complexity can be now virtually experienced and virtually visualized using AR and VR. We may find some excellent examples of augmented reality in education worldwide. Ability to connect reality and digital content has been steadily improving upon more options for opening more options for teachers and students. The way the augmented reality, for example, works, is that we have a computer generated data which is supposed to be augmented. For example, a human model which needs to be incorporated on a physical environment. So we take a physical environment and we combine it with a virtual environment, or we take a virtual environment, a virtual object, and we combine it with a virtual physical environment, which gives us the augmented reality environment. So for example, you take any product, you scan that product using mobile phone, and then a virtual data is augmented on your mobile phone. You take a real world environment, you pick up a particular virtual object, and then you combine them together, and it gives you a complete virtual field. Okay, this we do, and using this basic principle, we now are able to create thousands of applications involving virtual reality. So for example, in a mechanical environment of machines, you can just bring up your mobile phone in front of that machine, detect that virtual object or real object, and then present virtual information on that particular object. Similarly, tourism is again using the same concept, that you just hold up your mobile phone in front of your street. The street markers on the street location is identified, and then key virtual object are placed on your screen, identifying the locations of the restaurants or whatever placements you want to do. Similarly, industrial applications, medical applications are now being explored and being used to a greater extent. This is what virtual reality now allows us to do, and it opens new dimensions for research. It opens new dimensions for our learning paradigm. However, it relies very specifically on identifying marker points. This is where sometimes people tend to confuse augmented reality. Virtual reality does not rely on identifying marker points. Marker points are basically key high contrast points that are needed to be identified by your mobile phone, so that it can replace that identified point with a virtual object. When we do experiments, we use a certain black and white paper with a black marker to identify. Nowadays, the technology has enhanced, the vision technology has enhanced, that you can use live objects for tracking purpose as well. Okay, for an even more complex geometry. So for example, a map can be used to create a virtual 3D object completely. Similarly, any other locations can now be converted for that particular purpose. So you can use any real environment, scan it, have that as a marker point, and that can be used as a virtual object. So you can take any 3D object or any real object, scan it, create it as a marker, use it to replicate a digital information on the screens. So this is where information has progressed. Similarly, nowadays cars are being worked as well. So they identify a road, they use your GPS tracking, and they give you information. This is the same concept that has now been used in many, is being worked on in many cars, as well as in movies as well. You might have seen it in Iron Man or Spider-Man when they wear the glass called IDIS. Okay, so the same concept of AR, that it detects an object. Those objects are basically the markers. So as soon as it detects, the marker is processed, and then based on that marker processing information, a digital information is displayed on your screen. This is where augmented reality comes into play. Now, the same concept can be taken into education. The basic idea where we need to talk about. When AR and VR technology meets education, it has potential to be a major win-win situation. The main challenge in the development of custom VR education application then is that you have to create everything from scratch. This is one of the major aspects. That even whatever application you take, you have to keep in mind that you have to develop everything from scratch. There are possibilities that we can create certain apps for teachers that allow them to create VR applications more quickly and more fastly. But even for a teacher, that this is the major problem, major limitation, that you have to develop everything from scratch. If you take some statistics and analysis into account, 97% of the students would like to study VR course. This was done based on a survey, again, not from Pakistan region, unfortunately. This is an international survey that was conducted. Then 97% of the students would prefer using VR as an educational tool to understand their courses, to learn their courses. Education is expected to be the fourth biggest sector for VR investment. Fourth biggest sector in terms of financial gain as well. VR in education is predicted to be a 200 million industry by 2020 and 700 million industry by 2020 alone. Just VR, if you take for education sector, keeping every other sector aside, just for VR, this is how big an industry it is going to be. almost 80% of teachers have access to VR reality devices, but only 6.8% actually use them. So that is again a drawback. Because again, the creation of VR content is very difficult. So this is where our new research dimensions are heading, to be able to create more VR and AR tools for teachers in education. Tools, not only the outcome product, but creating an application that allow them, because not every teacher is a developer or a 3D artist or a graphic artist. So the dimension of the research dimension is not towards that we build a tool so that teachers can use those tools to develop their course materials easily and prominently. So the study shows that 80% teachers have the access to VR, but only 6% are using them because they are not expertise in that. So this is where the researchers and the scientists comes into play, or the developers, where they tend to develop these tools. 93% of the teachers said that their students would be excited to use this VR tool. 7 out of 10 teachers want to use VR to simulate experience that are relevant to materials covered in the class. So for example, using science, even if you take primary schools, one of our research projects was that we used virtual reality in primary schools. So to simulate simple scientific principles like photosynthesis. So if you teach photosynthesis to our children, it is more appealing if you use images, pictures. Okay, because if you explain certain scientific phenomena of just like photosynthesis based on theory, it becomes very difficult for a student to understand that what actually is going on. So you need some visual aid like pictures. So it helps students to understand that how photosynthesis is occurring. At the same time, if you now use tools like virtual reality, if you use tools like augmented reality to demonstrate the physical principle in virtual environment and allow the student to immerse themselves and understand how water droplets are basically being converted using photosynthesis into energy by the plants, and then how the water is being transferred from the stems to the cell. Using virtual reality, they can visualize these concepts. This has proved to enhance the learning of children to an extensive amount. Okay, and that is why we say that we use visual aids and VR to train and educate children, and this has a huge potential and a huge market in this latest 2020 era. Again, the survey continued, and while on average a regular student can remember 30% of what they hear, only 20% of they see. Okay, so this is what the statistics tells us, that only 30% on students can learn or remember basically what they hear. With VR and AR, the statistics confirm that students remember 90% of the material. See the change in this statistics. Only from 30%, when a student learns or hears something in a classroom, the 30% ratio was that they can only remember what they have heard. But if they use a VR, the study shows that 90% now remember what they saw in their virtual reality environment. So from a 30%, we jump to a 90%, which is a huge success and which is a huge gain in education. That by using VR and AR, you can increase the learning and the retention rate of a student, which is actually the primary goal of education, which is what we are trying to do. We are trying to educate so that students tend to learn. But if they only 30% of them remember what they're doing, then it's not a major success. But by using VR and AR, we can use and we can enhance that learning and retention rate to a substantial amount. Then again, VR and AR technology has proved that making the lectures, books, and exercises more immersive, interactive, riveting, and engaging with what they are becoming feasible solutions for seizing students' focus and attention. Okay, the students tend to be more interested. They are supposed to be more appealing while they are using AR and VR technologies. For example, materials for special children. This is where we basically are working with. We are teaching material, will design and create simple course booklets that will be used for cognitive guidelines as proposed by International Dyslexic Association, IDA, for dyslexic children. So we are trying to work on various different books that would be used by such special needs children. And then those children would use AR and VR technology for learning purpose. So what they do is they simply bring the mobile phones in front of the books, and then a VR-based object would appear explaining them various different principles. Each chapter and page of the book will be a marker which will be used to generate augmented reality objects. So this is one trend of education that we are trying to incorporate, where we design special books that behave as a marker as well. So the books are being used for learning as well as being used for augmented reality or VR application. So the child may just use those books to create augmented reality. Similarly, the same concept is being used in various different domains as well. For example, augmented reality based physics experiments. So physics experiments of various different principles, from magnetics to DC motors, from gravity to any other aspect that you want to cover. Nowadays, we have special books. We are designing for our, in terms of research based projects, where we design special books and we create a scientific principle based simulation, and the children is basically able to use that principle using through their mobile phones. Similarly, dynamic geometry based educations, where VR is being used to dynamically present a virtual environment where objects are there and the student is interacting with those virtual objects, trying to be able to understand, to see. So for example, square, cubes, hydras, polyhydras, spring, these objects, if you see on a physical environment, you see a physical environment. But in a book form, it becomes just a 2D image. But when you take that 2D image into a virtual environment, then student becomes more appealing, and then learning experience becomes more interactive. So this is another dimension that the research basically is being working on. Similarly, the narrative-based immersive collaborative environment, NICE, another project that was being worked on, is based on VR learning for children from 6 to 10, where biological concepts with immersive VR medium are being used. Like I mentioned, photosynthesis, like I've mentioned, water therapy, the water cycles, and other physical experiments where children are being presented with these virtual environments, and they see certain scientific principles that are in their books, but they see them virtually occurring, and their behavior and their learning skills is being analyzed, and their cognitive approach is being reviewed to see how much they are learning using VR. Similarly, VR for, I think I did that, VR is being covered in what we call science as well. There is an app that you can use called AR 3D Science. It uses a special marker points in terms of certain flashcards. You use those flashcards in your mobile phones, and then those flashcards basically represent your 3D object. Same principle. In this case, for example, your human body. And so whatever human body object you scan basically will give you a 3D information for that, which can be used for education purpose. AR animals, again, this is another app that you can use. This is available on your cell phones as well. It requires you to have these flashcards, which basically are again your marker cards. You scan those marker cards and then a 3D object appears on that object. Again, learning with that. Similarly, paleontology, again, is an app that uses dinosaur for 4D. This will tell you about various different dinosaurs. So again, you need to have that book as well. So many education sectors are using different educational applications for teaching children. Okay, and these applications are now basically purely based on VR and AR, and the results are very promising. That the amount of knowledge that people are able to gain and as well as retain is huge. So from a chemistry, which again is a very boring, to medical and biology, these applications are now being enhanced, and these are being used, and these are apps that are actually available on your Play stores. You can download them and use them, as long as you have these books as well. So you need those books as well, because these books would be behaving as a marker points for this study. Okay, so when we use AR, AR apps can be used in applications, and they can improve what we call the learning performance, the student engagement, and something called motivation to learn. These becomes the three major factors where we can bring and enhance the students for learning aspects. Other applications of these AR and VR in education can be training hazardous situations, critical skills, on-job training, compliance and training, employee on boards, extra, and so on and so forth. Military, gaming, serious game learning, and so on and so forth. So the dimensions of, or the research dimensions of using AR and VR in learning is huge. And there's a very vast area of environment where people can actually learn and understand through this latest tools available. Okay, so this is a simple brief talk about AR and AR. Thank you very much for listening. I would hope there are a few questions. I would love to take some questions if there are any.
Thank you so much, sir. Do we get question right now?
दूसरे भी क्वेश्चन नहीं है.
Okay, thank you so much, Dr. Zeeshan Bhatti.
Okay, thank you very much.
No.
Again, if any other queries, you can contact me. My email address is here. Any other research concept that you want to work jointly, I will be happy to do that. So don't forget, you can email me very easily. Okay, and I also have a YouTube channel where I constantly teach these 3D and VR aspects. So don't forget to tune in there, and you will find more to resources regarding that. Thank you very much, and thank you for the ILMA team and the conference chairs for inviting me to be part of this conference as a keynote. Happy to be here.
Thank you so much, sir. Let's proceed further now. I will recall again Mr.